Oh, and when will this air, Armando? When will it go on the air?
Yeah, we are live.
Oh, we are live.
Uh,
Okay,
yeah,
great.
hot. Our topic today is hot air and cold truth, the net zero crack up. And with us, Steve Gottenham. Steve is director of the Climate Science Coalition and author of 4 books. One of these books with over 100,000 copies in print. Welcome, Steve.
Hello, Armando. Great to join you again.
Thank you. And this is me. Okay. Steve sent a few slides. Please ask to share. I'm available here to share the slides you want. Steve, the first point, please. There's something related to global warming, and people saying that global warming is man-made. But do you have, or do we have data enough to prove, or the history of temperature, or things like that?
Well, climate is very uncertain, as you know. And so it's open to question in many ways what is causing the rise in temperatures. We have had a rise of about 100. We have had a rise over the last 140 years. And you mentioned 140 years in the information you sent me. That is a key date because that's when we first had thermometers, about 1880. But scientists use proxies, which are chemical changes in the environment which mirror temperature, tree rings or ice cores or oxygen isotopes, which tend to move along with temperature. And so they can go back farther. And if you want to put up the first slide,
Sure.
this shows two curves. The blue curve is the longest running temperature metric that exists right now. It's produced by the Met Office Hadley Center in the United Kingdom. It shows Central England temperature from about 1660 until today. So that's about 360 years. And it shows that, and they use both thermometers and proxies to do this. It shows temperatures have risen about 2 degrees Celsius in the last 360 years, about 3.5 degrees Fahrenheit.
Mhm.
And there has been a gentle rise, but then I've superimposed on top of that the orange curve, which is the annual human carbon dioxide emissions, the amount that is emitted every year, which started rising, 1900, but didn't really get very big until after World War II. And then you have to kind of scratch your head and say, okay, how did all these emissions change that Central England temperature curve? And there probably was a small change, but it's very, very slight. And this is just one piece of evidence that shows that human emissions may not be causing all of the temperature rises or changes that they say they have been.
So you mean that temperature is not related to CO2 emissions?
Well, I think it is slightly, but I think Earth's natural factors dominate global temperatures. And
Hmm.
if you go on to the next slide here,
Sure.
so this is a look at data from ice cores in Greenland, and it shows that temperatures, if you start at the right at zero, you go back about 10,000 years over on the left. That's the end of the last ice age. And then we see all these periods when temperature is changing throughout the last 10,000 years. And then finally, you get close to where we are today. And actually, our temperatures are not hotter than they were at many times over the last 10,000 years. And again,
Mhm.
this is not thermometer data. This is proxies of various types that produce this data.
Mhm. Mhm.
So the two things from this. One is that climate is always changing, and today's temperatures are not abnormally warm.
Mhm. Mhm. Interesting. Good point. Good point. It's 40 degrees Fahrenheit at this time. It's almost
Yep,
4 degrees centigrades in Brazil, in the city
yep,
I live. And but we know that parts of the U.S. had a major heat wave last month. But
yes.
is humans are responsible again, or is a media
Well, many
problem?
many have said that. Um, the And I'll read you a couple of quotes from articles here.
Mhm.
Our news outlet CNN said, quote, heat waves are getting more dangerous with climate change, unquote. And they also said that the current heat wave, quote, bears the hallmarks of human-caused global warming. NPR, National Public Radio, concluded that, quote, human-caused climate change has made this heat wave 3 times more likely. They were talking about the one a couple of weeks ago, due to emissions from, quote, burning of coal, oil, and gas, unquote. And Time said that heat waves now occur 3 times as often in the United States as they did in the 1960s. We also had Antonio Gutierrez, the
Good guy.
Secretary General of the United Nations, who just this last week, he was talking about the heat wave in Europe. And he said, quote, extreme heat is no longer a rare event. It's become the new normal.
New normal.
Yeah, so if you listen to all these things, you think, yeah, we've been having all these heat waves. Now let's put up one more chart. Go to the next one before we go on to the U.S. Temperatures, the Mendenhall Glacier. So this is an interesting piece of evidence, and I have many of these pieces of evidence I've gathered over the years. But the Mendenhall Glacier is located near Juneau, Alaska, in western Canada, northwestern Canada. And for many years, that glacier had been receding. And we even had environmental groups putting up posters in American airports showing how big the glacier was in 1880, and then a picture in about 1910 showing that it had shrunk way back. And the implication was that humans were causing it. But this photograph I'm showing you was taken from an ice cave underneath the Mendenhall Glacier. Scientists went inside this cave about 10 years ago and took these photos. And what the arrow is pointing to is a tree stump. And that brown thing there is about a foot in diameter tree stump. And it has roots still in the ground. They radiocarbon dated it, and it's about 1,200, 1,300 years old. It grew up during the medieval warm period. And they found many of these stumps. It wasn't just one. There were, maybe 100 of these or many more. And so the evidence shows that where today we have a glacier, a little more than 1,000 years ago, we had a forest in this area. Again, that's evidence that today's temperatures are not abnormally warm and that we've had warmer periods in the past. So now if we can go back to the US, if you go to next slide.
Next one.
What I've done here is plotted data from the National Oceanic and Atmospheric Administration. They have a database called State Extremes, which has all of the record high temperatures for a state. And it also has cold temperatures and rainfall and other things. But what I've done here is I've color-coded the decades in which the state highs have occurred. And if you look at this chart for a few minutes, you find first off that 36 of our 50 state high records, more than 70%, were set in the decade, or set prior to 1975, more than 50 years ago. And that big blue area of states, there are 23 states where the record was set in the decade of the 1930s, more than 90 years ago. So you go and you kind of scratch your head and say, wow, if it's so warm now, how come all of our state high records were many, many decades ago? And this points out again, this is more evidence that in many times in the past, we've had warm temperatures, and that current temperatures are a little bit warming. We've had some warming since 1880, about 1 degree Celsius, but really not abnormal in terms of climate temperatures, which we've had many warm ones in the past.
The red ones mean what exactly? So,
yeah, those are after year 2000. We've had 6 records set after the year 2000, state high records. Some of those were in the West, and then there's one down there in South Carolina. But you notice some of them, they've actually, the U.S. record for the highest temperature was set in 1913 in California, in Death Valley. 134 Fahrenheit. I don't know what that is Celsius, but it's very warm.
Specifically for California, 1913 was before 1920.
Yeah, that's the black. It's before 1920.
Yeah.
So again, we have warm temperatures, but then that gets on to the next question. I know you asked a question. What does adaptation mean and what is mitigation?
Yep. Yeah. Because for me, mitigation is a kind of attenuation, and adaptation
Yes,
is move according to demands. Is it
right.
correct?
Yeah, adaptation says we ought to just try and adjust what we do to the temperatures. Mitigation says we ought to actually try and go and change global temperatures
Mm,
by mitigating things. And most of the climatists, as I'll call them, say we need to stop emitting carbon dioxide, other greenhouse gases, and we will stop the climate from warming, a so-called mitigation. But there's really no evidence that we can do that, none at all. And people have adapted for all of the history of the world. And I'll give you a specific example. You can put up the next slide.
sure. Oops. This
Now,
one.
people point out that oceans are rising, and that's true across the world. The graph on the left is a graph I've taken from NASA, and I simplified it a little bit, took out some labels, but the graph is still there. NASA estimates that average sea levels have risen 120 meters since the last ice age, and that's 390 feet. And no climate scientist can tell you when natural sea level rise stopped and man-made sea level rise began. And over on the right, there's a picture of a tide gauge there. The best tide gauges show that oceans are rising at a rate of about 7 or 8 inches per century. It's higher in some places and lower in others. But the climate movement seems to think that we can stop ocean rise. And you look at this data and you got to kind of scratch your head. The only rational policy is to adapt to rising oceans, as Netherlands has done for centuries. They've built seawalls and islands and for the rising oceans so that they don't flood the nation.
So you mean that the left one, the left chart, 20,000 years ago, the
Yep,
sea level was 120 meters
lower.
below this lower.
This is one estimate from NASA, and there's some places where the relative level is rising more. If you go to the eastern U.S. seacoast, if you go to Texas or Florida or Virginia, you find that the relative rise is maybe 15 inches a century or 20 inches a century. And the reason there is the land is actually subsiding. The land is sinking, and a lot of people think that's because we're pulling a lot of fresh water out of the land under the water table underneath. What we should be doing probably is desalination of seawater to get fresh water and not taking it from the land underneath. Alaska, I was just up there and spoke 3 weeks ago. Southern Alaska the oceans are actually falling because the land is rising in southern Alaska. When you melt the ice, and this is still a rebound from thousands of years ago, when you melt the ice that was in Alaska, then the land tends to rebound because it's not so much weight on it. So, but again, the only sensible policy for climate is to adapt. If we think we can all drive electric cars and stop the oceans from rising, there is no evidence for that.
Yeah, you mean adapt because you do not have strength enough to mitigate. Is the point?
Well, that's right, and there are other examples too. And we know we have hurricanes in the Caribbean, but the way to strengthen cities and people against hurricanes is to raise the level of income of nations, build very strong concrete structures, and try and prevent that sort of thing. There's no way that we know of to stop hurricanes by changing our light bulbs or putting up wind turbines. That is very, very tenuous.
Good evening, Paula Kerber. Thank you for coming. It's a pleasure to have you here today. Thank you. Steve, there is a wave in the world trying to go to the net zero level and the targets in 2050. U.S. is out of this game. What exactly is, or is a boycott of the federal government? What's
Yeah.
exactly happening?
Well, things are turning around fast. There are many things happening. And by the way, we have had, if you want to put up the next chart, many of our
Sure.
states have had net zero electricity targets. And this basically says that we would have net zero carbon dioxide emissions by some date in the future, typically 2040 or 2050. And the goal here is to force the adoption of wind and solar for our electric power sources and to get rid of coal and natural gas in particular. But all of these targets are now in jeopardy because of a number of things going on. The first is what President Trump is doing. And if you want to go to the next slide.
Sure. 1 second.
I call this an upheaval here. First, he has dropped the bomb on renewables. He has halted all licenses for offshore wind. And we had many states on the East Coast, about 10 of them, and then we have California and Washington and Oregon on the West Coast that have wanted to put in wind turbines offshore. But he's no longer going to issue licenses for those. He's just stopped that. The second is he's canceling funding for wind energy and solar and other mandates. And what just happened today, I think we're going to talk about, is the big beautiful bill is about to be
congratulations. I know that was approved by Senate. You mentioned
how we'll talk about that in a minute, but that really cuts all of these tax credits.
Please explain a little bit more. What are the main points of this approval?
We'll go on to the big beautiful bill. So back in 2022, the Inflation Reduction Act was passed by the Joe Biden administration, President Biden, and it increased hugely the amount of payments that are made to renewables. By the way, we've been subsidizing renewables in the United States wind since about 1992, and they keep adding subsidies, and they're continuing. In the administrations prior to Mr. Biden, the U.S. government was paying about $10 or $15 billion a year in the form of production tax credits, investment tax credits, loans, and outright grants. And
all these for wind energy.
Well, it was wind and solar, and it was some other things, biofuels. But for example, an investment tax credit allowed you to take a tax credit for 30% of the cost of your project. And if you couldn't use those credits on 30%, you were allowed to sell those to other companies, those credits. And so it was a big value. And then there were some state things as well. So almost a half of a project for a wind system would be paid for by the government. Now, the big beautiful bill, though, cuts all that out. It says you have to get a project online within, I'm not sure what the latest language is, but it's, you have to start producing electricity within like 2 years. I think it's the end of fiscal year 2027 or something, or you can't build the project. And there's a whole bunch of other things that have been cut for green hydrogen and a lot of things. So anyway, this passed the House today. It had passed the Senate, and Mr. Trump is planning on signing it tomorrow afternoon. So this is going to have a tremendous impact on wind and solar. By the way, the wind and solar people always say wind and solar is the cheapest form of electricity. But then right after that, they say, yeah, but we got to continue all these subsidies for wind and solar.
Yeah, but at the same time, Paula is saying drill, baby, drill. What's the difference between these two approaches? Let's drill, baby, drill for oil and gas, but let's reduce the renewable investments. Is there let's say a logic behind this?
Well, I think there is. Chris Wright, who is the new energy secretary, and Doug Burgum, the Secretary of the Interior, have come out very strongly. They say we need that wind and solar are actually parasitic on the system. When you put in wind and solar, you have to, because they're not always on, they're not on at night for solar, and when the wind doesn't blow, you have to keep the backup systems always ready to run. The coal or the natural gas or the hydropower. but you have to reduce their utilization. So it gets so they can't break even anymore because they're running at 30 or 40% of capacity. So Chris Wright and Doug Burgum have said we need to get rid of these parasitic things. We need to go back to reliable, always on, dispatchable electric power. And that's nuclear, and that's natural gas, that's coal, and that's hydropower, which you have a lot of in Brazil.
Mhm.
And so they actually want to reduce the subsidies for all of these. And, there are some cases like if you're in Hawaii, you have no pipelines out there and it's always windy and always sunny. It's a great system. Some other places in the South. But in many cases, it's not really helping the power in the United States. It's actually hurting the reliability of the grid.
Yeah, because to keep natural gas or other coal available all time when renewables fail, so it's a big problem. It's not something.
Yeah, you have to have two
fair.
plants. You have to have the wind and
Exactly.
solar, and then you also have to have the backup plants.
Exactly.
And we just saw what happened in Spain as well, where they went to all
Yeah,
solar, and in 5 seconds, power went down for 60 million people in Spain because they had these things there's a stability issue as well with wind and solar. They don't have the inertia of spinning turbines, and so they can fluctuate and go down more easily.
Steve, what's the relationship between artificial intelligence demand for energy and renewable? There is nothing related to these two things.
Yeah, let's pop up the next slide. So,
oops, yeah.
In the United States, we've had flat electricity demand for many years. In other countries as well. In the United Kingdom, electricity demand has been declining for 2 decades in the United Kingdom. That's partly because they've been moving plants offshore. Germany's demand is down in a lot of these places. But all of a sudden now we have this artificial intelligence revolution. We have people building data centers all over the world. Ireland is one area. In the U.S., they're building many of them. Mr. Huang, I'm forgetting his first name, of NVIDIA just went to Europe, and he talked to Germany, and he talked to England, and the Prime Minister of England said, wow, we're going to go AI. We're going to build all these systems with NVIDIA. The problem is that these need huge amounts of electricity. And so what's happening in the United States right now is we have power plants that are being extended that were scheduled for shutdown. Coal plants in Tennessee, Utah, West Virginia, Indiana, there's a number of other ones I'm not mentioning, are now being extended past the dates they were going to close because they need the power. We're restarting two nuclear plants, one in Michigan and one in Western Pennsylvania. And then the other thing is we're building large amounts of gas plants. Over 200 are in planning or under construction. And all of these are needed to meet the rising power demand to provide power to these data centers. And oh, by the way, we even have some companies like Microsoft and Amazon that are building their own power plants, Tesla as well.
Yeah,
it's called BYOP, build your own power. And so they're building their own gas plants rather than hooking to the grid to power. So this is what this means, though. You can't provide reliable 24-hour power with wind and solar. And so this is another thing that is really impacting the net zero shift. And it's basically between the Trump administration and this demand for artificial intelligence, net zero really is just suffering.
Yeah. Paula Kerber is asking you, nuclear fusion is not the future, she is asking.
Well, I think it could be. A good question, Paula. So nuclear fusion, the problem is the cost and all of the regulations.
And the time to put available.
And the time. Yeah, today you can put in a gas plant in about 3 years, and nuclear takes you a decade.
Yeah.
So what we need some cost breakthroughs in nuclear. I'm hoping that the new small modular plants will enable us to have lower cost nuclear plants and build those quickly. I also presented a group a while back in the pipe industry, plastic pipe, and the guy says if I ship plastic pipe to a company, usually it takes 1 or 2 sheets of paper and paperwork. If I ship it to a nuclear plant, it takes 1 or 2 inches of paperwork. I mean, the amount of regulations are just really huge. So I think that the Trump administration is looking at trying to streamline that and promote nuclear around the country. We also have Sweden, we have Italy, we have a number of places in Europe. Even Germany is reconsidering nuclear plants now. So there's a chance for nuclear to come back, but we need a cost reduction.
So you mean that your thoughts are that nuclear is more a dream than reality? Is it correct or?
Well, we'll see. Again, I think the big winner is going to be natural gas, but nuclear can do it if some things change. And there's also some possibility for geothermal. The new fracking techniques that are used to get oil and gas under the surface of the earth can also be used to create heat fields for geothermal. So we'll see if that comes along as well.
Yeah. In your book, Green Breakdown, you mentioned that renewable energy has a chance to be collapsed. For me, it's very difficult to understand this assumption, but how?
Well, I think we're going to have a mixed future. We're going to have a mixed hydrocarbon renewable future, but there are many places, not only in the United States, where people are losing their concern about a man-made warming. A good friend of mine, Dr. Benny Peiser, who was at the Global Warming Policy Foundation, he was a chairman in Europe. He looks around and says, wow, people are just kind of pushing back on this. In Germany, we have the Alternative for Deutschland that got 30% of the vote a year ago. They have in their plank to ban wind turbines. We have an alternative party under Nigel Farage in the UK now that is calling it net stupid zero is what they're using for their terms. So it's not only the United States. I think around the world, we have these issues coming up, and people are realizing the cost with trying to get to net zero and how it's really tough. By the way, another thing is green hydrogen. Everybody's real high on green hydrogen. That is collapsing worldwide. I'm getting ready to write an article on that. But I think people are going to return to sensible, low-cost energy. By the way, Green Breakdown's fun book. It's a color paperback, or you can get an ebook if you're down in Brazil.
Is it the last one?
Yeah, this is the last one here. So this one's a sidebar in Green Breakdown. This is actually a headline that they had a New York Times essay said that you should mate with short people to help save the planet and help stop global warming. But the book is filled with all these sidebars that are a lot of fun.
So if someone buy in Amazon or other place, you can send to the buyer here in Brazil?
I can, yeah. Or it'll come from Amazon. Now you can get ebooks as well, but they can go to my website, Steve Gorham, GOREHAM.com, and I can send them a signed copy as well.
Yeah. Before you go, if I give you $100 in your pocket now, in which energies, three most important ones for you, you would put money?
Probably natural gas right now. Gas is growing. It's the biggest in the U.S., and soon it's going to be the biggest in world electricity production. Right now, coal is still the biggest source of electricity in the world, 35%, but I think gas is going to take that over. So we'll just have to see. But I think natural gas really, by the way, Canada just started shipping liquefied natural gas from British Columbia for the first time. All their gas was going through the United States. They're shipping it to the Pacific. Alaska is going to build a liquefied natural gas terminal. We have a lot of places that are building gas right now.
So the first one is natural gas for you.
I think so.
Yeah. Before you go the second time, Paul Kerber is asking you, who controls the production of energy in the world? Probably is this question.
Well, maybe I think I wouldn't want to be in the position Europe is in, where they're importing just about everything, all of their gas and many of their other products. But it's sort of a mix. Many people like Brazil. Brazil, you have great hydropower. Canada has great hydropower. Those are big advantages. They're non-polluting and they're low cost.
Yeah,
biofuels,
so it's a mix. Ethanol.
It depends on the location.
But the point of Paula probably is more a geopolitical view.
Yeah.
Who are controlling in terms of, let's see, you said that a mad environment, a mad.
Well, we have, the markets are pretty competitive now. Gas used to be a local, regional thing, and now it's competing with what's importing with liquefied natural gas. Yeah. We have the U.S. is shipping propane to Asia, and India, for example, is distributing propane canisters to all their people. energy is becoming more worldwide, and so it's pretty competitive markets now for all of these things.
Yeah.
But it's expensive. LNG is more expensive than locally produced gas, so it can be a cost for a nation.
And the United States is very strong in natural gas at this time, and oil, of course, is
Yeah, we're the biggest producer of oil and gas in the world.
14 million barrels per day is a big production.
Yeah.
Huge. Brazil is only 4, but it's growing very fast.
Yep.
Steve Gottenham, it was a pleasure. Thank you so much for this conversation today.
Thank you, Armando. Until the next time.
Next time, sure.